Hello, my name is Mirko Peters, and I translate how technology actually shapes business reality. Most conversations about Power Apps start in the wrong place because people want to debate screens, buttons, or user adoption. They might talk about automation for a moment, but then they wonder why the app feels unstable 6 months later. If you look closely, the failure rarely starts in the app layer, and it actually begins much deeper in the data foundation that everything else depends on. This isn't a tool discussion. This is a system behavior discussion with direct business consequences. Because Excel and SharePoint lists feel fast and familiar, teams use them as structural compensation for needs they were never built to carry. The app grows and the process spreads until AI gets added, which makes governance painful and turns every later fix into expensive rework. We need to start where the real behavior begins, and that means looking underneath the app at the foundation itself. The hidden cost pattern most teams miss. The first mistake most teams make is measuring the wrong kind of cost. They look at what they already own, noting that Excel and SharePoint are already there and ready to use. A list takes 5 minutes to create, while a spreadsheet takes 2. So a Canvas app on top of that feels like genuine progress. From the outside, that looks efficient because the budget stays low and delivery looks quick, which makes the team feel resourceful. But that first impression only measures entry cost. It ignores coordination cost, and coordination cost is where fragile systems start charging interest. This clicked for me when I saw how often leaders compare Dataverse to SharePoint as if the only real variable was the price of the license. That comparison sounds practical, but it strips out the part of the system that hurts most later, which is the human effort required to keep it running. Human effort is not a rounding error, and it is exactly where the business pays for weak structure every single day. You're not saving money, you're shifting cost from licenses to complexity. And why is that? When the foundation can't hold the operating load, the people inside the process start inventing workarounds to get their jobs done. They copy data into another list because permissions don't work cleanly, or they export to Excel because the report can't answer a basic question. They send status updates in email because the source record can't be trusted, and eventually they build their own tracker because the shared one is already drifting from reality. Now nobody trusts the first record, so a second one appears, then a third. Then someone creates a reconciliation step just to compare all three. At that point, the organization thinks it has a process problem or a training problem, but the reality is usually a structural problem. The architecture made inconsistency cheap, so inconsistency spread throughout the department. That matters more than most teams admit. Once workarounds become normal, they stop looking like exceptions and start looking like the actual process. The business adapts around the weakness, and managers add review meetings because the data can't speak for itself anymore. Analysts spend hours checking versions because the status field means something different in each place. And operations teams delay decisions because they can't tell which number is current. It's a system outcome. And the cost pattern gets worse over time because each local fix adds more surface area to the problem. More fields, more copies, and more side channels appear alongside undocumented logic living in inboxes and habits. The system starts negotiating with itself before it can do any useful work, which slows down every person involved. This is why familiar tools can feel efficient at the beginning and incredibly expensive later on. They reduce startup friction, but they increase dependency on manual coordination, and that trade looks harmless until the process is under real pressure. Take reporting as an example. A team starts with a simple list, but then another team needs the same data structure differently, so they duplicate it. A manager eventually wants a dashboard, but since the key fields aren't consistent, someone has to clean the export before every single meeting. Nothing looks catastrophic in the moment, but each report now depends on cleanup work, which means the business has no real-time truth. Or take approvals. If the record structure is weak, every approval includes a layer of interpretation that shouldn't be there. People ask what version they are looking at or who owns it, and they waste time hunting for the latest attachment or the right list. The delay isn't caused by the approval itself, but by the system failing to present a clear state to the person making the decision. Ownership breaks the same way. If a customer or a project exists in multiple places, then accountability fragments right along with it. Everyone touches the process, but nobody owns the truth. And once nobody owns the truth, every decision gets slower because it starts with validation. That is the hidden cost pattern most teams miss. The visible tool stays cheap while the invisible operating cost climbs through labor, rework, and trust erosion. Because those costs sit across different departments instead of on one invoice, they rarely get blamed on the foundation, but they should. Because before we can talk about Dataverse properly, we need to separate one thing very clearly. Storage is not the same as behavior. Dataverse is not about storage, it is about behavior. When I tell you that Dataverse is the right foundation for your business, I'm not starting with a storage argument, I'm starting with a behavior argument. That distinction is vital because most teams hear the word database and immediately reduce the conversation to where records sit. They think in containers, imagining this table lives here while that list lives there or that file sits in a specific folder. But operational systems are not actually defined by where data rests. They are defined by what the structure permits, what it blocks, what it remembers, and what it enforces while your people are actually doing the work. Dataverse matters because it does much more than hold records. It carries rules, it carries relationships, it carries ownership, and it carries identity. This gives the entire system a way to behave consistently, even when the number of users, processes, records, and automation starts growing. That is a very different job from a spreadsheet. And it is also a different job from a list. A spreadsheet is great when one person needs flexibility, and a list is useful when a team needs lightweight tracking. But business operations do not stay lightweight for long, and the moment multiple teams touch the same object, the problem changes completely. Whether it is a customer, a case, an asset, a project, or a request, you no longer need simple storage. You need controlled behavior across a shared reality. This is where Dataverse changes the game, and I use that phrase carefully. It is not because the tool is flashy, but because it changes what the platform can actually guarantee for the business. For example, relationships stop being optional. If an approval belongs to a request, and that request belongs to a project, and the project belongs to a customer, that structure can be modeled directly. You are no longer copying customer names across 3 different places and hoping people spell them the same way every time. The context moves through the relationship itself. That changes behavior. Typed columns change behavior too. A date is a date, a currency value is a currency value, and a choice is a defined choice. The system stops accepting vague inputs that look harmless in the moment but become incredibly expensive 6 months later. Validation stops being a polite suggestion and starts becoming part of the operating surface. Ownership changes behavior, security changes behavior, and audit history changes behavior. Once the platform knows who can see what, who changed what, and which record belongs to which process, the people inside that process stop negotiating basic facts every time they touch the work. And why is that so important? Because most friction in business systems is not dramatic, it is just repetitive ambiguity. You've probably heard these questions before. What does this status actually mean? Which record should I trust? Who is allowed to update this? Why does this report show something different? Was this field changed, or was I looking at the wrong version? Dataverse reduces that ambiguity by making structure part of the system rather than part of team memory. That is the part many people miss. They compare Dataverse to a cheaper storage option and ignore the enforcement layer, but the enforcement layer is the whole point. If the structure is optional, drift is inevitable, and once drift starts, every app, every flow, every report, and every AI experience inherits that instability. So let me put it simply. Dataverse does not store your data differently. It forces your business to behave differently. It does that by narrowing the space for inconsistency, which means fewer duplicate definitions, fewer side channels, and fewer local interpretations of what a record means. That does not remove complexity from the business, but it does remove unnecessary variation from the system carrying that business. And that is what good architecture should do. It should not make things look advanced. It should make things hold. If you remember nothing else from this section, remember this. A data platform is really an operating model in technical form. It decides whether truth can stay shared when pressure increases. It decides whether automation runs on clean states or messy guesses. And it decides whether governance feels natural or bolted on later. Once you see Dataverse through that lens, the comparison with SharePoint and Excel becomes much clearer. We are no longer asking which tool is easier to start with. We are asking which foundation can keep the business coherent when the load goes up. Why familiar tools create fragile systems under pressure? Now map that to the tools most teams start with. Excel is a brilliant personal productivity tool, and I still use it myself. Most of us do because it is fast, flexible, and forgiving, which is exactly why it works so well for individual thinking, rough analysis, and one-off coordination. But none of those strengths make it a shared operational backbone. In fact, the very flexibility people love in Excel becomes a liability once the file turns into a business dependency, because flexibility without enforcement invites silent divergence. One person adds a column, another changes a formula, someone downloads a copy, and someone else emails a version. Now the team is not working on a record anymore. It is working on interpretations of a record. That is fine for scratch work, but it is fragile for operations. SharePoint lists sit in a slightly different category, and this is where people often get confused. A SharePoint list is more structured than a spreadsheet, and for lightweight tracking, that matters. It is useful for collaboration, especially when the process stays close to a single team with low volume and simple status management. So I'm not arguing that SharePoint is bad. I am saying it has a design center, and that design center is not enterprise relational operations across growing processes, security boundaries, and cross-team dependencies. From a system perspective, that is not a criticism. It is just scope. The problem starts when the business quietly changes scope, but the foundation does not. A list that worked perfectly for one team becomes the basis for an app, then another team needs access, then reporting expands, and then approvals become more complex. Then audit questions arrive, someone wants role-based visibility, and an executive asks why the dashboard does not match what operations sees on the ground. At that point, the system is under pressure, and pressure reveals design intent. The tool is doing exactly what it was set up to do. It is just not set up for what the business now needs. This is why fragility appears late. Early adoption feels like success. because the app launches fast, users engage, and everyone feels pragmatic because no premium decision had to be made upfront. But the success is often misleading because the test conditions were gentle. Low data volume, limited roles, minimal process branching, and few dependencies all make a weak structure look strong. Then load increases. And load does not just mean more records, it means more joins between teams, more exceptions in the process, more access rules, more automation, more scrutiny, and more demand for trusted reporting. A foundation that looked efficient at low pressure starts creating friction everywhere at once. Take auditability as an example. In Excel, reconstruction is manual, and in SharePoint, change history exists, but not with the same operational depth as a platform built around business data, security, and server-side logic. When someone asks who changed a field, what the previous value was, and whether that change affected downstream decisions, the answer often lives across versions, inboxes, exports, and memory. That is not an audit trail, it is an investigation. Cross-team access creates the same pattern. SharePoint permissions can work for many scenarios, but as complexity rises, teams often compensate by creating extra lists, filtered copies, or parallel stores just to manage visibility. Once access control drives duplication, the security problem becomes a data problem. Now you do not have one truth with controlled visibility. You have multiple truths with partial overlap. That is a single point of failure multiplied. Analytics exposes the weakness too. Leaders ask for one report, but the data shape underneath was never built for relational reasoning at scale. So analysts start cleaning, mapping, and stitching before they can answer basic questions. The report may still get delivered, but the operating model behind it is unstable because every answer depends on reconstruction. And this is why familiar tools create false confidence. They lower the barrier to starting, but they do not remove the architectural requirements of growth. They postpone them. Then later, when the business depends on the process, every missing structural decision comes back at once. The first crack usually appears in the data shape itself, because that is where weak foundations stop hiding. Flat data versus relational data. So let's look at the first structural crack in the foundation, which is the actual shape of your data. Flat data feels simple because it puts everything in one place, giving you one row, one record, and one long list of columns that looks clean at first glance. A customer name sits right next to the request sits next to the status, and the status sits next to the owner. Then someone adds project details, approval notes, a region, a cost center, and an asset ID, until suddenly that single row is carrying pieces of 5 different business objects. That is the exact moment simplicity turns deceptive, because flat data does not preserve context, it simply copies it, and copying context is where inconsistency begins to rot the system. If the same customer appears in 50 different records, then that customer's truth now exists in 50 different places. If the account manager changes, you don't just update one relationship, you have to update 50 rows, or you update 12 and leave 38 of them completely wrong. If the region name gets entered slightly differently each time, your reporting starts splitting one business reality into several fake ones. North region, and N region all have the same business meaning, but because they are different stored values, you get 3 different answers in your dashboard. People usually call that dirty data. I prefer to call it predictable data. The structure allowed for repetition where the business actually needed a reference, and this is where relational data changes your entire operating logic. Instead of copying the customer into every single transaction, you relate the transaction to that customer one time. Instead of storing a project name in every approval, you connect the approval to the master project record. That might sound technical, but the business effect is simple. Context travels through relationships instead of manual duplication. And why is that so powerful? It's powerful because now one single truth can support many different uses without being rewritten every time the process moves forward. A one-to-many relationship is the easiest place to see this in action. One customer can have many cases, one manager can approve many requests, and one project can contain many tasks. In a flat model, you keep repeating that parent information across every child row, but in a relational model, the child points back to the parent, and the parent carries the shared truth for everyone. So when a customer changes their address, or a project changes owners, or a manager moves to a new department, you only update the thing that actually changed. The connected records inherit that context from the relationship itself, rather than relying on a copy-pasted value that is already starting to drift. Many-to-many relationships matter just as much, especially once your business reality stops fitting into tidy little hierarchies. Think about people assigned to multiple projects, assets linked to multiple service events, or approvals that involve more than one stakeholder group. Flat tools usually try to fake this with extra columns, comma-separated values, or duplicate rows. But all of those approaches eventually collapse under reporting and security needs because the relationship exists only in human interpretation, not in the data model. Dataverse handles this differently because relationships are first-class parts of the model itself. The structure acknowledges that business objects depend on each other, which means the system can reason across records without asking users to recreate meaning in every single field. This matters in very ordinary, everyday scenarios. A customer record should not have to be rebuilt every time a service case is opened. A project should not carry copied budget labels across every task just so your reporting can function. An asset should not be typed into a text field on every inspection if the business needs to see lifecycle history, ownership, and service context later on. That is the shortcut nobody teaches you. Relationship design is not some technical luxury for architects. It is the structural guardrail that prevents the same business truth from fragmenting into dozens of local, broken copies. I sometimes explain it this way. Flat data treats every record like a self-contained sentence, while relational data treats records like connected parts of the same language. That is why one model scales effortlessly and the other eventually starts contradicting itself. And once those relationships matter, your query behavior starts to matter too, because a good structure only helps if the platform can actually reason across the full dataset when people ask real questions. Delegation, thresholds, and the 5,000 item illusion. Once relationships matter, scale stops being an abstract problem for the future and starts becoming a truth problem in the present. This is exactly where many power apps built on SharePoint begin to mislead the people using them. The phrase most people hear is the 5,000 item threshold. Because they hear that specific number, they assume the rule is simple: stay under 5,000 and you're safe, but go over 5,000 and things break. That mental model is wrong, and it creates a dangerous kind of false confidence for the builder. Because the real issue is not just how many rows exist in the list. The real issue is where the thinking happens. If a query can be delegated, the data source does the heavy lifting by filtering, sorting, and evaluating across the full data set before sending results back to the app. If the query cannot be delegated, Power Apps starts pulling a limited subset locally and reasons over that smaller slice instead. In practice, that usually means the app only sees 500 rows by default, or maybe 2,000 if someone went in and manually changed the app settings. Now pause and think about that for a second. You might have a list with 18,000 records, and when a user opens the app, everything looks normal. Search seems to work and a filter returns results, but the app may only be evaluating the first 500 or 2,000 records for parts of that logic. That means the app is not slow in the way we usually think about performance. It is incomplete. And having incomplete data in an operational app is actually worse than having visibly broken data, because people will act on that information with total confidence. This is the 5,000 item illusion. Teams think the threshold is a wall they will eventually hit, but often it's just a warning sign they've already passed. The real damage starts much earlier, when delegation breaks quietly and the app continues to function just well enough to hide the underlying problem. SharePoint can store far more than 5,000 items, and that part is technically true. The issue is that large list behavior combined with non-delegable queries in Power Apps changes what the app can reliably know about your business. Search, complex filters, and certain formula choices can push evaluation away from the server and onto the client device. Once that happens, the app stops reasoning over the whole truth and starts reasoning over a random sample. From a business perspective, that is not a technical nuance. It is a massive decision risk. A manager thinks no high-priority request exists because the matching record was sitting outside the delegated slice. An operations team thinks an approval queue is clear because the app never evaluated the full set of data. A dashboard looks current, but the underlying query only considered a fraction of the records. Now, trust starts dropping, and nobody can see why, because the app still opens and still appears to be alive. The people inside the system don't usually say they have a delegation problem. They say the data feels off, or the app misses things, or they simply don't trust the report anymore. And they are absolutely right to feel that way. This is why Dataverse changes the conversation entirely. Dataverse supports full delegation for standard operations like filter, sort, search, and lookup across massive datasets. The app keeps asking the platform to reason at the source, not at the screen, which ensures users get answers based on the full dataset rather than whatever subset the client happened to inspect. This is also why people underestimate the pain of migration later. If you build a process on SharePoint and only discover these delegation limits once the app is business critical, you aren't just tuning a formula anymore. You are confronting the fact that your foundation cannot reason at the scale your process now requires to survive. And that becomes expensive very fast, because scale problems are not only about speed, they are about maintaining truth under load. A slow query is frustrating, but a partial answer that looks complete is corrosive to the organization. It damages your reporting, your automation, and your team's confidence all at the same time. So when someone tells you SharePoint can hold a lot of data, they are telling you something that is technically true. But the real question you should be asking is different. Can your app think across all of that data reliably when your decisions depend on it? If the answer is no, then your storage volume is not a win condition. It is just proof that the wrong foundation lasted a little bit longer than anyone expected. Data quality collapse is usually a system outcome. Once scale starts distorting what your application can see, the next failure usually shows up in the trust you place in your data. When this happens, most teams look for someone to blame, and they almost always point their fingers at the wrong target. They blame the user. We've all heard the complaints before. Someone picked the wrong status, someone forgot to update the owner, or someone created a duplicate record for the third time this week. Maybe someone typed the customer name differently or broke a lookup field. That story feels reasonable because a human being touched the field. But if your structure makes inconsistency the easiest path, then bad data isn't just a user error. It is a predictable output of the design. It's a system outcome. I've seen this pattern repeat across dozens of organizations where teams complain that data quality is tanking, yet the model itself accepts almost anything. You see text fields where a defined choice should exist, free typing where a relationship should be enforced, and optional fields that the entire process actually depends on. When you have multiple places to capture the same fact, without a structural rule deciding which one wins, you aren't managing data, you're managing chaos. In that kind of environment, bad data is not an exception to the rule, but rather it becomes the path of least resistance for everyone involved. Duplicates are the most obvious example of this structural failure. If a customer can be entered manually every single time a request is created, then duplicates are not a surprise. They are almost guaranteed. One person writes the legal name while another uses the trading name, and then someone else adds an extra space or shortens it to fit a specific screen. Now your reporting splits one customer into 4 different versions, your automation misses critical records, and your teams waste hours asking which account is the real one. The same thing happens with stale values that lose their meaning over time. A copied field might look accurate on day one, but the moment the source changes and the copy stays the same, you've created a lie in your database. Status fields drift the same way when different teams interpret the same word differently, such as when in review means waiting for approval to one group but active work to another. One label with 3 different meanings results in a system with no shared state. That is not a training issue first. That is architecture debt. Because if the system does not define meaning tightly enough, people will naturally fill that gap with their own local interpretation. And local interpretation is exactly how data quality collapses the moment you try to scale. Dataverse changes that pattern by moving quality control directly into the platform itself. Data types are explicit, relationships are modeled, and choices are strictly defined so that required fields can be enforced before a mistake happens. Business rules can validate inputs before bad records have a chance to spread into your flows, reports, and downstream apps. The point here is not to make the system feel restrictive, but rather to remove whole categories of cleanup work that never should have existed in the first place. This is where one source of truth stops being a corporate slogan and starts being a functional reality. In a well-structured Dataverse model, the customer record is the only customer record, and every case, project, or approval points back to that single object. That means when something changes, you change the truth exactly once instead of hunting through 12 different places where you might miss one. And when you commit to that structure, the business starts to see a compounding return on its investment. You deal with less reconciliation and less manual checking. You stop correcting the same mistakes every Friday, and you finally end the debates about whose spreadsheet is actually current. That is time back, but more importantly, it is trust back. Data quality is not just about technical correctness. It is about whether the people inside the system believe a record can carry a decision without extra verification. The moment they stop believing the data, they will create side systems like personal lists, private notes, and manual exports to compensate for the failure. Now, your poor data quality is actively generating even more poor data quality in a spiral that is nearly impossible to stop with policy emails. And that spiral only stops when the model itself narrows the room for inconsistencies. So if your organization is spending hours deduplicating records or fixing broken lookups, don't start by asking who entered the data wrong. Start by asking a harder question. What did the structure permit? Because once data quality improves at the foundation, your process speed starts changing with it, and that is where the operating model finally begins to feel different. Cycle time falls when the system stops negotiating with itself. Once your data quality improves, something else changes that leaders feel almost immediately. Your cycle time starts to drop. This doesn't happen because people suddenly started working harder or because the app got a prettier interface. Cycle time falls because the system finally stops negotiating with itself before work is allowed to move forward. That negotiation is a hidden tax found everywhere in weak architectures. A request gets submitted, but the owner is unclear, so the process stops while somebody asks who is supposed to approve it. The approver finally opens the record, but the status logic is inconsistent, so they have to ask whether the file is actually ready or still missing a key document. When an attachment lives in one place and comments live in another, the process pauses while people try to reconstruct the context. None of that looks dramatic on a high-level dashboard, but together, these moments create a very expensive form of waiting. And waiting is usually not a human productivity issue first. It is a coordination issue produced by the structure of the system. This is why I often tell leaders that slow processes are rarely slow because the work itself is difficult. They are slow because the system keeps forcing a human to interpret the data between every single handoff. One person enters data, another tries to understand it, a third checks if it can be trusted, and a fourth sends an email to confirm what should have been obvious. The process is moving, technically, but it is moving through a thick layer of structural friction. Dataverse changes that dynamic because it gives Power Apps and Power Automate a stable operational core to work from. Records have defined shapes, relationships carry their own context, and rules enforce the state of the work at every step. That means your automation can trigger on something the platform actually trusts, and your people can act on records without revalidating the basics every time they open a screen. That is a very different operating model from the typical email-led approvals and list-driven workflows we see in most offices. In weak systems, every handoff contains translation work. In stronger systems, the handoff contains state. That difference is much bigger than it sounds. If a request enters an approval phase in Dataverse, the record already carries the required fields, the right parent object, and the allowed next status. Power Automate doesn't need to chase clarity through complex side logic or exception handling because the structure underneath it is already coherent. So the process gets faster, not because automation replaced the people, but because the system removed the avoidable ambiguity that was slowing them down. And this is the part many teams miss when they talk about automation ROI. They assume speed comes from replacing manual clicks, and while that is sometimes true, most operational speed comes from removing interpretation loops. A manual approval is not always slow because a person touched it. It gets slow when the record arrives incomplete, duplicated, or detached from the context needed to make a choice. That is why structured entities and one source of truth actually matter for your bottom line. When those pieces hold, your flow design gets simpler, your exception handling shrinks, and the process starts behaving more like a pipeline than a messy conversation thread. I've seen organizations think they need better reminders or stricter SLAs, when the real issue was that the system kept handing people records that still required a phone call to explain. Once you fix that structural gap, the performance shift can feel disproportionate as days become hours and rework virtually disappears. The process stops feeling busy and starts feeling direct. That is not magic. It is what happens when the record arrives ready for action. So, if you want faster delivery, don't start by looking at the workflow diagram alone.
Start underneath it by looking at the data shape, the ownership model, and the relationship design.
Because process speed is not only an automation question, it is a structural clarity question. And once that clarity is in place, another layer becomes possible, especially in regulated environments where speed only matters if you can trust how the work moved. Auditability changes the operating model. This is where speed alone stops being enough for a growing business. In any serious environment, especially once approvals start affecting money, contracts, or regulated decisions, the question isn't just how fast the work moved. The real question is whether the system can actually prove how it moved. And that shifts the standard for every team involved. Most teams treat auditability like documentation after the fact, which is usually just something you try to reconstruct once a problem finally appears. Someone asks who changed a specific field, when it happened, what the old value was, and whether the person had the right access to trigger that downstream action. Then the scramble begins as people start digging through file histories, email chains, flow runs, and personal memories to piece it all together. That isn't governance, it's forensic work triggered by weak infrastructure, and it's a massive drain on resources. Dataverse changes this dynamic because audit history becomes a built-in memory inside the operating layer itself. On most customizable tables, the platform tracks data changes, user activities, and security modifications automatically, so the record is no longer just a snapshot of the current state. It carries a permanent trace of how that state was reached, which matters more than most leaders realize. Once the platform can answer who changed what and when it happened, several things shift at once. Troubleshooting gets faster, security reviews get cleaner, and compliance work stops being a theatrical performance for auditors. Operational trust rises because the business no longer needs to reconstruct history from fragments scattered across 5 different tools. And this is where it becomes relevant for anyone responsible for systems. Think about what this does to your everyday decision-making. If a status changed unexpectedly, you can simply inspect the history instead of debating whose version of the truth is right. If a workflow behaved strangely, the team can trace the record path instead of interviewing everyone who might have touched it. The system starts carrying its own evidence, which is a very different operating posture from reactive reconstruction. This lowers costs in a way many teams miss, but it's not because audit logs are free. Dataverse audit logs consume storage, and heavy auditing on high change tables can increase storage pressure or even slow things down if you enable it carelessly. This isn't a pitch for turning on every switch forever, but it is an argument for being intentional about what the business truly needs to remember. That distinction is vital for a healthy system. Good audit design is selective, focusing on critical tables, sensitive fields, and meaningful business events rather than endless background noise. Recent platform improvements like per-table storage management and retention policies exist because Microsoft is effectively telling us that memory has value, but unmanaged memory has a cost. Leaders need to think about auditability as infrastructure rather than a checkbox. You have to ask what the organization must be able to prove and which records carry real regulatory risk. You need to decide how long that history stays in Dataverse and what should move to long-term storage for analysis. Once you ask those questions, governance stops feeling like bureaucracy and starts looking like capacity planning for trust. This is where the operating model truly changes. In a weak environment, audit work only begins after someone gets suspicious, but in a stronger environment, traceability is continuous. The organization doesn't have to panic and assemble evidence from inboxes because the evidence is already part of the platform's memory. It changes how people behave across compliance and leadership because accountability is no longer a special event, it's just normal. There is another effect to consider as well. When teams know the platform records meaningful changes consistently, those local side channels and private spreadsheets lose their appeal. Hidden edits and parallel trackers become harder to justify because the official record is now the accountable record. That strengthens trust in the model itself. Auditability supports compliance and helps with investigations, but structurally, it does something much deeper. It gives the system a reliable past, and a system with a reliable past can support decisions with far less friction in the present. Which brings me to the next layer, because once traceability is part of the foundation, governance stops looking like overhead and starts acting like infrastructure. Governance is not restriction, it prevents collapse at scale. This is usually the point where people tense up because the moment you say the word governance, many teams hear the word delay. They hear forms, approvals, and central control from people who are far away from the actual work being done. I understand that reaction because bad governance often feels like friction added from the outside, but that isn't the kind of control an operational platform needs. It needs structural control that keeps growth from turning into chaos. In low-code ecosystems, freedom without boundaries doesn't stay innovative for long. It quickly turns into app sprawl, duplicated entities, and multiple truths trying to answer the same business question. For a few months, that might look like momentum because you have lots of makers and lots of apps. Then you wake up 6 months later and nobody knows which app is official, which flow is safe to change, or why two departments have different definitions for the same customer. That isn't agility, it's unmanaged divergence. Once that divergence spreads, scale becomes incredibly expensive and risk becomes harder to see. Change gets slower because every update might break something hidden, and while the organization thinks it moved fast, it actually just created a larger surface for failure. Governance in Dataverse and the Power Platform should be framed as continuity control. It's the set of decisions that lets many builders contribute without dissolving the integrity of the whole system. Start with your environment strategy, which sounds administrative but is actually a prime example of governance acting as infrastructure. Development, test, and production environments are not just ceremony. They are risk boundaries that separate experimentation from reliability. Without that separation, teams end up testing in live systems and patching directly in production, which slowly trains the business to accept instability as a normal way of life. That might feel fast in the moment, but it's expensive later because every live fix teaches the platform to drift further away from reality. Then you have data loss prevention policies. People hear that and think restriction, but DLP is really just a way of deciding which kinds of data movement the organization will allow to become normal. If those boundaries are unclear, makers will combine connectors in ways that look harmless locally but are dangerous globally. Sensitive data starts crossing services without any shared intent, and the problem isn't that people are careless, it's that the environment never told them where the safe edges were. Ownership matters just as much as the technical settings. If an app exists in production and nobody can clearly answer who owns the flow or the business definition underneath it, then you don't have a scalable asset. You have a dependency with unclear accountability, and those always fail badly because the governance questions arrive at the exact moment the operational pressure is highest. This is why role design is so important. It's not just about security roles in a technical sense, but operational roles regarding who can build, who can approve, and who decides when a local solution becomes enterprise infrastructure. If those lines stay vague, every successful small app becomes a candidate for accidental business criticality. It happens all the time. A small app solves one team's problem, then another team adopts it, then a flow gets added, and suddenly leadership is referencing a dashboard built on top of it. The thing that started as a local convenience has become operational infrastructure, but the governance model never evolved to support it. That is where the collapse begins. When leaders resist governance because they fear it will slow down delivery, I usually push on one specific point. Unmanaged freedom doesn't actually remove control. It just relocates that control into hidden places, undocumented logic, and silent risk that you eventually have to pay for. You still pay for control, you just pay for it late, and you usually pay for it during a major failure. Good governance pays earlier and loses less. I see it as business continuity for low-code platforms because it protects shared definitions, deployment paths, and sensitive data. It protects the people inside the system from inheriting a platform that looks productive on the surface but is fundamentally unstable underneath. Once you see it that way, governance stops sounding like a restriction and starts looking like a load-bearing structure. That is exactly where the next issue appears, because when that structure is weak, security rarely stays clean. It starts forcing copies and side systems just to make access work at all. So here's the question I'd leave you with. If you audited your governance the same way you audit your systems, what would you find? And more importantly, is that system designed to sustain your growth, or is it slowly creating a single point of failure that will drain you over time? Security that does not force data duplication. Security is usually the first place where a weak architecture reveals itself, because the moment people cannot cleanly control who sees what, they start copying data to compensate. A manager might need access to one specific part of a list but not the entire thing, so someone creates a second list to solve the problem. Regional teams should only see their own records, so the data gets split by geography into separate silos. One department should not view a sensitive field, so the record gets exported, trimmed, and stored in a completely different location. Now, your security problem has transformed into a duplication problem, and as we know in systems design, duplication always becomes a truth problem later on. This is one of the most expensive patterns I see in operational setups that rely heavily on SharePoint. Permissions can absolutely work in SharePoint for basic collaboration, but when teams try to stretch that model across growing business processes and sensitive data, they often compensate with structure outside the platform. You see hidden lists, local copies, and team-specific trackers appearing everywhere. These process branches exist only because the original access design could not hold the model together under pressure. That is not secure architecture, it is fragmentation disguised as control. The business consequence is much bigger than most people expect because once security drives duplication, every single copy begins to drift. One team looks at one version of a customer while another team updates a parallel record, and eventually a report pulls from the wrong place entirely. When an automation triggers from a partial data store, your access control has quietly damaged your operational coherence. Dataverse changes that pattern because the model can stay whole while visibility changes based on the user's role. This is where role-based access control actually becomes a business tool, rather than just a technical feature. The same record can exist once inside one controlled model, and different people see different things based on their team, business unit, or specific field permissions. That is a completely different design outcome from copying a record into 5 places just to hide certain parts of it. So let me put that in business language. You do not need 3 versions of the truth. You need one truth with controlled visibility. That sounds obvious, but structurally it changes everything for the organization. Once the data remains centralized, collaboration improves because teams are no longer comparing separate records during meetings. Trust improves because every report comes from the same operational object, and support improves because the app logic does not need to chase exceptions across multiple stores. Security improves because access is enforced at the platform layer instead of through improvised workarounds that people eventually forget. Field-level security matters here too, especially when a record must stay shared, but specific parts of it should remain restricted. Salary information, pricing details, and internal risk markers do not always require a separate process, but they often require a stronger model. Dataverse supports that stronger model by letting the platform carry visibility rules closer to the data itself rather than forcing the process to fracture around sensitivity. And once that happens, something subtle but important changes in how people behave. Teams stop building parallel systems just to feel safe, and they stop hoarding private exports because the official system no longer exposes too much or too little. The record becomes usable across many different roles without becoming universal in the wrong way. That is where good security starts reducing complexity instead of adding to it. Canvas apps connected to many external sources often struggle here because the security logic gets distributed across too many places. Part of it lives in the source, part lives in the formulas, and another part lives in the sharing settings. That can work for a while, but it creates more opportunities for your policy to drift over time. Dataverse connected apps, and especially model-driven apps, simplify that by letting the data layer carry the policy consistently. Which brings me to a hard truth that leaders need to hear early in the process. If your security model is weak, your data model will fragment to compensate. Once that fragmentation begins, the cost does not stay trapped inside the security budget. It spreads into your reporting, your automation, your support, and ultimately your trust in the system. Access design is not a side discussion for the IT department. It is a core part of architectural resilience. The same question keeps showing up in different forms. Can the business share one operational reality without breaking control? If the answer is yes, then scaling the business gets much easier. If the answer is no, copies will begin multiplying and every copy becomes another slow failure waiting to surface. If no one owns the data model, everyone reinvents it. Once your access is stable, the next fault line appears higher up the stack in the form of model ownership. This is where a lot of organizations get into trouble because they treat the data model like a technical artifact instead of an operating decision. A table gets created, a few columns get added, and then another team extends it for their own needs. A second app needs something similar, so it creates a near copy with slightly different names to avoid a meeting. Nobody stops to ask the harder question, which is not whether we can build this, but who is allowed to define what this thing actually means for the business. If no one owns the data model, everyone will eventually reinvent it. That is not just a theory. It is what happens in almost every fast-moving low-code environment that lacks clear stewardship. One team calls a record a client, while another calls it a customer, and a third uses account to mean something much narrower. Status values begin to drift, relationships get approximated, and local fields appear because they solve immediate pain for one person. 6 months later, reporting cannot reconcile the entities, and leaders start hearing different answers to the same question depending on which app they asked. That is semantic drift, and semantic drift turns directly into a massive operating cost. Because once shared objects lose their shared meaning, every integration becomes tedious translation work. Every dashboard becomes an argument about definitions instead of a tool for insight, and every new app starts from field discovery instead of from established truth. The business thinks it has a tooling problem, but what it really has is a naming and ownership vacuum with technical symptoms. Now, some organizations try to solve this by giving ownership fully to the IT department. That can help with consistency, but it creates another risk where IT protects the architecture while drifting away from process reality. The tables stay neat and tidy, but the model stops fitting how work actually moves through the office. Then the business starts building around the model instead of through it, and those side systems return. Other organizations swing the other way and give ownership fully to the business units. That sounds empowering on paper, but it often creates the opposite problem where the model matches local language but ignores reuse and enterprise consequences. The structure feels useful right now, but it becomes incredibly expensive to maintain later. So the stable path is usually a hybrid form of ownership. Business ownership of meaning, technical ownership of structure, shared ownership of change. That means process leaders help define what a customer or a project actually is in operational terms. Platform and architecture leaders then shape how that meaning becomes a durable model inside Dataverse with relationships and lifecycle in mind. One side without the other creates drift, but together you get a model that reflects reality and can still scale. This is why naming is not cosmetic and definitions are not just for documentation. They are executive choices with technical consequences. If leadership allows every department to define common objects differently, then fragmentation is not an accident. It is a funded outcome. And that outcome spreads quietly through the organization. A field gets added in one app because nobody wants to sit through a governance meeting. Another team cannot use it because the meaning is unclear, so they add their own field to the same table. Then an integration maps both fields poorly, and reporting needs a manual bridge to make sense of the mess. Now, a tiny naming shortcut has become a structural dependency with a permanent support cost attached to it. This is also where data councils and architecture reviews can help, but only if they stay practical and fast. If governance turns into abstract committee work, people will simply route around it to get their jobs done. But if ownership is visible and tied to actual operating objects, then teams stop reinventing the same truth under different labels. So before you try to scale Dataverse, ask a very plain question. Who owns the business meaning of the core entities? I'm not asking who can edit a table or who built the first app. I am asking who owns the truth those records represent across the entire organization. Because if that answer stays vague, the platform will still grow and apps will still ship. But underneath all of it, the model will start splitting into local dialects. And once that happens, your scale becomes sprawl with better branding. Environment strategy decides whether growth becomes scale or sprawl. Once ownership is clear, the next decision is where change is allowed to happen, because even a well-owned model can still collapse if the platform grows in random places. This is why environment strategy matters much earlier than most teams think. People often treat environments like admin plumbing, calling them dev, test, prod, or sandbox. But from a business perspective, these are not just containers. They are risk boundaries that decide where experimentation can stay experimental and where production can stay trusted while the business keeps running. If you ignore that, growth does not turn into scale, it turns into sprawl. Sprawl in Power Platform is sneaky because it often begins with good intentions when someone needs to solve a real problem fast. They build in the default environment because it is there, then another team does the same, and eventually a maker leaves while an app keeps running. A flow still triggers, and a connection belongs to someone who changed roles 6 months ago, creating a fragmented system that nobody planned. The platform fragments because the system allowed local convenience to become the permanent operating structure. That is a system outcome. The reason environment strategy matters is simple. Innovation needs boundaries if you want it to become repeatable. Without those boundaries, every app becomes its own little island of assumptions, connectors, permissions, and undocumented choices. That can look productive from the outside because things are getting built, but inside the platform, trust starts thinning out. Support teams cannot see clear release paths, security teams cannot see where sensitive data is moving, and business owners cannot tell which app is the one that actually matters. And once trust drops, speed drops right after it. So let me take one step back. A healthy environment strategy usually starts with one basic principle. Development is not production, And production should never behave like development just because nobody wanted administrative friction. That means having a place to build, a place to test, and a place to run. We do this not because process theater looks mature, but because every system needs a safe way to absorb change without teaching the business to expect instability. When teams skip that separation, they create silent coupling. A maker changes a table directly in a live environment, a flow gets updated to fix one issue while quietly breaking another. And a connection reference behaves differently than expected. The app still opens, so everyone assumes the change was safe until a downstream process fails 2 days later. Now, the organization is not only dealing with a bug, but it is also dealing with the fact that nobody can clearly explain how change entered production in the first place. That is not scale, that is operational gambling. The default environment deserves special attention here because it becomes a fragmentation engine in many tenants. It feels convenient and lowers the barrier to entry, but if serious apps and business-critical automations start accumulating there without a clear policy, the platform slowly loses architectural shape. Dependencies get buried, ownership blurs, and governance has to discover assets after they already matter, which is always late. A stronger approach is not to stop people from building, but to route that building through intentional lanes. Personal productivity use cases can stay lightweight, while team experiments live in managed spaces with visibility. Shared production apps move through environments with clear ownership and deployment paths, which is how experimentation becomes enterprise capability instead of accidental infrastructure. There is also a compliance angle people underestimate. Environment design affects where data sits, how policies apply, and how confidently changes can be reviewed. So environment strategy is not just for admins, it shapes supportability, audit posture, and executive confidence in whether the platform can grow without becoming opaque. If you remember one thing here, remember this: unmanaged environments do not create agility. They create hidden dependencies that only become visible during failure. So before the next app gets built, leaders need to answer a plain question. Where are people allowed to experiment? Where are they allowed to test? And where is the business allowed to depend? Because when those boundaries stay vague, scale does not emerge from growth. Sprawl does. Without ALM, every update is a gamble. Once environments are clear, the next pressure point is change itself. Even with a strong model and sensible boundaries, the platform still has to evolve. New fields get added, flows change, security roles shift, and a rule that worked last quarter no longer fits the process now. Change is normal, but the risk begins when change has no controlled path into production. That is where ALM enters, and I want to keep this very plain. Application lifecycle management is just the discipline of moving change safely. Not eventually, and not when the platform gets big enough, but from the moment something matters. Without ALM, every fix is personal. A maker edits directly in production, someone patches a flow because users are waiting, or a table gets changed to support a local request. It works, or it seems to work, but nobody can say with confidence what changed or what depends on it. There is no way to know if it was tested somewhere safe first, or how to go back if the update creates damage 2 hours later. That is not low-code agility, that is fragile release behavior. And why is that so dangerous? Because low-code creates a false sense of safety. The interface feels accessible, so people assume the consequences stay small, but a production power app tied to Dataverse and reporting is still a live business system. If you edit it carelessly, the business absorbs the risk whether the change came from a traditional developer or a citizen maker. The system does not care who clicked save. It only reflects whether change was controlled. This is why solutions matter, versioning matters, and a defined deployment path matters. These are not developer rituals imported from somewhere else. They are how you keep a platform trustworthy once people depend on it. In Power Platform terms, that means packaging components properly and moving them between development, test, and production in a predictable way. Because if you do not package change, you cannot govern change. And if you cannot govern change, you cannot scale confidence. I've seen teams move quickly for months by editing apps directly where they run. It feels efficient right up until the moment a field rename breaks a flow or a rushed fix solves one pain while creating 3 hidden ones downstream. Then everyone suddenly wants documentation, rollback, and testing after the failure has already happened. But those things only work well when they exist before the incident. That is the hard lesson. Delivery speed without release discipline creates downtime debt. You may not see that debt in month 1, but you feel it in month 9 when production changes become stressful and support teams lose confidence. Business owners start saying, please do not touch anything until after quarter end, which is a sign that the operating model has become defensive. That is usually the sign that trust in releases has already been damaged. So what does a better path look like? Build in development, validate in test, and promote to production intentionally. Use versioning so you know what changed, and use managed release paths so rollback stays possible. Treat apps, flows, and schema as one moving asset, not as disconnected edits scattered across makers and environments. That is what turns low-code from convenience into infrastructure. And there is another point leaders should hear clearly. Low-code without ALM does not stay simpler than custom code. It often recreates the same fragility with friendlier screens. Hidden logic, undocumented dependencies, and personal knowledge sitting inside one builder's head create a single point of failure. It just arrived wearing a productivity story. So if your platform is already supporting live operations, ALM is not optional maturity for later. It is the condition for making change safe now, because once the business depends on the app, every update already carries operational risk. The only real question is whether your release model acknowledges that risk or keeps pretending every edit is harmless. Why model-driven apps reveal the value of Dataverse fastest? Once you have ALM under control, the next hurdle is purely practical. You have to make the value of Dataverse visible quickly, or the organization will keep treating it like an expensive, abstract platform choice. For most enterprise teams I work with, the fastest way to bridge that gap is through model-driven apps. And why is that? It's because model-driven apps start exactly where the real work starts, with the data model itself. While that sounds simple, it fundamentally shifts the conversation from the very first day. In a Canvas app, you can actually hide a weak structure for a long time by designing around it. You might build a polished screen or use complex formulas to mask inconsistencies, making fragmented data sources feel coherent for a single user session. That flexibility has its place, but it often delays the moment of truth while the foundation stays messy underneath a pretty interface. Model-driven apps take the opposite approach. They expose the model. Forms are generated from tables, views emerge from relationships, and dashboards pull from that same governed structure. Because the business logic sits right next to the record instead of being scattered across screen behaviors, the app becomes useful the moment the model is strong. If the model is weak, that failure becomes visible immediately, which is actually a massive system advantage. The platform stops letting us confuse a nice interface with actual operational quality. This is why I tell leadership that model-driven apps reveal the truth of Dataverse fastest. They force everyone to confront the factors that actually determine scale, like whether the business has agreed on entities, ownership, and roles clearly enough for the platform to generate a usable surface. Once those structural pieces are in place, the system handles the heavy lifting without the usual custom coding effort. You get standardized forms for updating records and views that ensure every team is looking at the same filtered reality. By layering in business rules and process flows, the app starts guiding human behavior instead of just displaying empty fields. That is where the value becomes concrete for the business. It isn't about a flashy UI, it's about the operating model finally showing up on the screen. When a request has a clear status and every owner has a defined responsibility, the app starts behaving exactly how the business process was meant to function. Most enterprise teams don't actually need infinite interface freedom. They need consistency. They need a repeatable surface for record-heavy work that functions across every department and device. If your process depends on people routing and updating structured records all day, these apps usually fit that reality much better than people expect. There is another reason this shift matters. It effectively ends the obsession with UI. I'm not saying the user experience is irrelevant, but model-driven apps change where your team spends its energy. Instead of arguing for 3 weeks about button placement while the data model remains vague, the team has to make hard structural decisions early on. They have to define the tables, the valid state transitions, and the specific roles that need access. That discipline might feel a bit slower at the start, but it removes a massive amount of confusion down the road. The app becomes a perfect mirror of your architectural clarity. If that sounds a little rigid, that's actually a good thing for most enterprise environments. Service processes, case management, and approval chains aren't design playgrounds. They are coordination systems where consistency and compliance matter more than visual novelty. When you can show a leader the same record through different roles, demonstrating how permissions in history emerge from one model, the conversation changes. It stops being about the cost of storage and starts being about how to run shared operations without rebuilding logic in every single app. Canvas flexibility versus Dataverse control. But Canvas apps still matter, and this is where many people turn a good architectural question into a false choice. They ask if Canvas is better than Dataverse, but those aren't competing layers. One is a way to shape a specific experience, while the other is a way to govern the truth. If we confuse those two jobs, we end up blaming the front end for problems that were actually created in the back end. Canvas apps feel fast because they are incredibly fast to start. You can plug into SharePoint, Excel, or SQL Server and immediately shape an experience around a specific task or a mobile device. For a field worker who needs a simple flow or a frontline team that needs a tailored screen, Canvas is often the right call. But that same strength creates a significant structural risk. When a Canvas app connects to a dozen different sources, the logic starts to spread out and thin. Security is suddenly split between the source, the app sharing settings, and individual formulas, while validation might live in a specific control or nowhere at all. A record might look unified to the user, but underneath the hood, It's being assembled from systems that completely disagree on access or meaning. Now map that to how we work today. A team builds a beautiful app on a SharePoint list and an Excel file, and because it looks great, leadership assumes the architecture is sound. What they are actually seeing is interface quality compensating for a weak foundation. The screen looks coherent, so the underlying structure escapes the scrutiny it deserves. This is why I always say that most app failures don't start on the screen. They start in the model. If your data shape is weak, the flexibility of a Canvas app can hide that weakness much longer than a model-driven app would. You can patch over problems with collections and local workarounds, but every one of those moves your business logic into a place where it's harder to govern. From a system perspective, that isn't flexibility, it's just distributed fragility. This is exactly where Dataverse-connected Canvas apps become interesting. Once the app sits on top of Dataverse, the user experience stays tailored, but the policy layer moves down into the platform where it belongs. Security roles still apply and relationships still carry context, which means the app no longer has to carry the full burden of maintaining order by itself. That changes the entire operating shape of your solution. You still get the custom interaction and the role-specific design, but now the record underneath has one governed definition. This is the hybrid reality I recommend most. Use Canvas where the experience is the priority, but use Dataverse where truth and control are required. Let the front end stay flexible, but never let that flexibility dictate the meaning of your underlying business objects. This matters for security more than most teams realize. Canvas apps pulling from external sources create a scattered security posture, but Dataverse narrows that spread significantly. The user still sees the tailored interface they want, but their access is grounded in a consistent, manageable layer. I'm not arguing against using Canvas apps. I'm arguing against using Canvas freedom as a substitute for architectural discipline. Canvas is for shaping the interaction. Dataverse is for shaping the control. When you make them work together, you get a custom experience sitting on top of governed data. The app can move fast without forcing the model to fragment, and that is how you build a real operational backbone instead of just another local app. Scenario 1, shadow app chaos to one operational model. Let's make this concrete, because these concepts stop feeling theoretical the moment you look at how business processes actually grow in the real world. A team hits a snag, and it's usually a very real, very frustrating problem where work is buried in email threads and nobody can see the status of anything. Approvals take forever to move. And by the time the end of the month rolls around, reporting has to be stitched together manually from 5 different places. So someone does the sensible thing and creates an Excel tracker to keep their head above water. Then they move it to a SharePoint list because the team is growing. And eventually a Power App appears to make data entry easier, while a flow starts sending out automated approval emails. None of this starts as bad architecture, but rather as local problem solving under intense pressure. And for a while, it actually works. That is exactly why this pattern is so dangerous, because success arrives long before structure does. Now, map out the typical expansion of that success. One team uses the tracker, but then another department wants their own custom fields, a manager demands a dashboard, and finance insists on adding one more approval state. Someone eventually adds a second list because the permissions are getting awkward, so attachments go to a document library, while the actual conversation stays trapped in email. The app points to some of the data while the report points to the rest, and while everyone believes they are working on the same process, structurally they are not. They are navigating several partial realities that only appear connected because the people inside the system keep compensating for the gaps manually. This is what I call shadow app chaos. It isn't chaos because the app is hidden in some dramatic way, but because the operating model itself is hidden from view. The business can no longer see where the truth lives, who has the right to change it, or which specific object is actually authoritative. Work continues, but the trust holding it all together starts thinning out. You can usually spot this phase of the cycle pretty quickly. People start asking, which file is the current version? They spend the first 10 minutes of meetings comparing exports. Approvals get rechecked in chat because the system isn't trusted. Reports require a full reconciliation before anyone feels comfortable sharing them upward. Nobody wants to delete the old tracker because nobody fully trusts the new one to hold the weight. That last point is the one that really matters. If you cannot retire your old tools, then your new system hasn't actually become the system yet. This is where many organizations think they need a better interface, when what they actually need is a single operational model to ground the work. They need one Dataverse model with one definition of entities where requests, customers, cases, and status transitions live in relation to each other. These things shouldn't be copied between tools, but modeled once and then surfaced through the right app experience. That shift changes much more than just where you store your data. It removes entire categories of coordination work that used to drain your time. The request automatically points to the right customer record. The approval state is defined once for everyone. Ownership is visible directly in the record. Automation runs from the same source that the reporting reads. Security controls access without forcing you to create duplicates. Now, the process is no longer held together by memory and goodwill, but by a structure designed to sustain it. I have seen teams who thought they were building a better app when what they were really doing was removing 11 competing truths and replacing them with one governed process backbone. That is the real win for the business. It isn't about prettier screens or more automation in isolation, but about having fewer places where the business can contradict itself. Once that happens, the difference is obvious even without looking at the statistics. Before the shift, every exception required a deep investigation, but after, the record already carries the context you need. Before, reporting was a negotiation between departments, but now it's just a projection of the same operational data everyone sees. Before, every process change created a new side system, but now changes are made in one model and inherited across the entire solution. The emotional shift is just as important. People stop feeling like they need to maintain private safety nets, and they start trusting the live record instead of rebuilding context from their inboxes. They stop keeping parallel notes just in case the system fails them. That isn't just a story about user adoption, but a sign that the system has started absorbing complexity instead of pushing it outward onto the people. If you want to find the right first use case for Dataverse, don't start where the excitement is loudest. Start where the shadow systems are already multiplying and where the team has one process but 5 different places that pretend to run it. Start where reporting requires a translator and approvals require detective work, because that is the moment where Dataverse stops looking like a technical upgrade. It starts looking like relief. Scenario 2, why AI fails without structured grounding. This same pattern becomes even more obvious the moment AI enters the picture, because a lot of organizations are hitting a new frustration curve right now. They connect Copilot, experiment with agents, and ask natural language questions across their business data, only to act surprised when the answers feel shallow or unreliable. The first instinct is usually to blame the prompts, the model quality, or the user training, but in most cases, that isn't where the failure is happening. The failure starts much lower in the stack. AI simply does not reason well over a scattered operational truth. If your underlying data is spread across files, lists, and inconsistent status values, then the model isn't sitting on business context. It is sitting on fragments. It can still generate language and sound very helpful, but sound and structure are not the same thing. When the structure is weak, the AI's confidence rises much faster than its actual accuracy. That is a dangerous combination for any business. If you look closely, AI disappointment is often just a data architecture story wearing an interface story as a disguise. Leaders often say the assistant isn't intelligent enough, when what they really mean is that their information doesn't exist in a usable operational shape. The model cannot infer what the business never bothered to model clearly in the first place. This is why Dataverse matters so much in the next phase of the Microsoft stack. It isn't because AI magically lives inside it, but because Dataverse gives AI something much more useful than sheer volume. It gives it structure. It provides tables with defined meaning, relationships that carry context, and a governed operational layer that an agent or copilot can reason over without ambiguity. And that difference is massive. A customer record by itself is just a row in a table. A customer related to cases, approvals, tasks, and history starts becoming actual context. That is the level where AI finally gets useful, because usefulness doesn't come from having more text alone. It comes from having a model that preserves how things actually belong together in the real world. Dataverse provides that through relational structure, which is exactly what weak file-based estates usually fail to provide for the user. They store facts, but they do not hold meaning together consistently. Microsoft's own direction makes this very clear. Dataverse is being used as the central operational source for Copilot and custom agent scenarios, including experiences where users can summarize records and move directly into actions. That only works well when the data underneath is coherent enough to ground the interaction. Otherwise, the AI layer just inherits the same contradictions the humans were already struggling with. When I hear teams say that AI is not ready, I usually translate that a bit differently in my head. The AI may be ready, but your operating data is not. That is a very different diagnosis for a business leader, because one leads to prompt workshops and tool shopping, while the other leads to model design and ownership clarity. One is a cosmetic fix, but the other is a structural solution. This is where a lot of Copilot ambition quietly collides with business reality. Organizations want conversational access to their operations, but those operations were never designed as one trustworthy model. They were assembled over time through convenience, and AI exposes that weakness fast, because weak grounding stops hiding the moment you ask for reasoning. The system can only answer from what it can actually trust. If you want better AI outcomes, do not start by asking how to make the assistant sound smarter. Start by asking whether your business objects are defined clearly enough that an assistant can tell what belongs to what without guessing. Because AI is only as intelligent as the structure it sits on. Once AI connects to that structure, another design question shows up immediately. Where should the operational truth live, and where should the broader analytics happen without overloading the system that runs the work? Dataverse as the operational operational core, not the analytics warehouse. This is the exact moment where many teams accidentally create a second architecture problem right after they've finished solving the first one. They finally get their operations centralized in Dataverse, and suddenly everything starts working the way it should. The records have actual structure, your automation runs cleaner, and your AI finally has solid grounding to work from. But then someone in the room asks that very familiar question. This is great. So can we just use Dataverse for all our reporting, our entire history, and every future data need we might ever have? It sounds efficient, and it definitely sounds tidy. But if you look at it from a system perspective, that move confuses two very different jobs. Running your day-to-day operations is one job. Analyzing those operations at scale is something else entirely. Dataverse is built specifically to support your operational layer, which means it excels at transactions, structured records, and managing process states. It handles relationships and security while acting as the living system where your people create, update, and route the data they need to actually do their work. That is what the system is designed to do. It holds the current truth that your business is actively using right now. However, the moment leaders try to turn that operational store into a universal analytics warehouse, they start loading the wrong expectations onto the platform. The reason this fails is that analytics asks fundamentally different questions. Analytics isn't just asking what is true in this moment. It wants to know what changed over time across massive volumes of data, how patterns evolved over years, and how that data joins with finance, web, or external systems. Those are broad projection questions, not operational ones. When you force one single platform to do every job at once, one of those jobs is going to start suffering. The much cleaner design is to separate your data by its purpose. You should let Dataverse run the actual work, while letting another layer carry the heavy lifting of analytical projection. In the Microsoft ecosystem, this usually means using Azure, Synapse Link, or Fabric Link to move your data into an environment built for history and cross-source modeling. This allows for deep reporting without putting all that technical pressure back on the live store that's trying to run your business. This separation isn't just about following architecture trends or duplicating data for fun. It is a matter of workload discipline. Your operational system needs to stay responsive and trustworthy because it's tied directly to your business processes. Meanwhile, your analytical system needs room for bigger joins and time-based thinking. These needs are related, but they are not the same. If you treat your operational core like a warehouse, you're asking it to carry patterns it was never meant to handle, and that's usually when people start blaming Dataverse for things that aren't its fault. I see this happen most often when teams expect every single report to read directly from the live store with zero latency and no architecture for high change volumes. Analytical pipelines have their own specific behaviors. While Synapse and Fabric Link support near real-time patterns, the standard expectation is usually a 15-minute sync cadence rather than some magical instant reflection across every report. In high-volume situations, those delays can even stretch a bit further. Leaders need to stop asking for everything at once and start thinking in business terms. You have to decide what needs the live operational truth right now and what can accept a governed analytical lag in exchange for better scale. That is a much more productive conversation than trying to force one platform to satisfy two conflicting instincts. There is also a real cost and complexity dimension to consider here. Forcing an operational store to satisfy every reporting pattern creates pressure in all the wrong places, while analytical links come with their own storage and governance choices. Fabric might simplify the experience, while Synapse offers more engineering control. But the point isn't which one sounds newer. The point is choosing the right projection layer for the specific job you're trying to do. Good architecture separates systems by their purpose, not by what's currently trending. If Dataverse is your operational backbone, then you need to treat it like a backbone. Let it carry the live records, the process states, and the automation triggers that actually run the business. Then project that data outward into analytical layers when your questions become larger, slower, or more historical. By doing this, the business gets the best of both worlds, a trustworthy operational core and a reporting layer built for actual analysis, rather than one overloaded foundation trying to pretend those two things are the same. Audit history, retention, and the cost of remembering everything. That same logic of separation shows up again when we talk about audit history. The moment Dataverse becomes your operational core, a new instinct usually kicks in, the desire to keep everything forever. Now that you can finally see who changed what and when they did it, that instinct feels like safety. It provides accountability, helps with investigations, and supports your compliance needs. Essentially, it gives the platform a memory, but memory is never free. If you look closely, your audit strategy is actually a design choice about what the business needs to remember, how long it needs to remember it, and what you're willing to pay for that privilege. Dataverse auditing tracks changes across your tables, but those logs are stored in premium log capacity. This matters because auditing isn't just a nice-to-have feature running invisibly in the background. It consumes a specific storage category. And if you turn it on for everything without a plan, your costs will start rising quietly while you assume you're just being responsible. This is exactly where teams run into trouble. They start treating auditing like an all-or-nothing moral decision. The fear is that if you don't audit everything forever, you're risking a total loss of accountability. But that framing is far too simple for how real operations work. Some records carry heavy regulatory weight, while other changes only matter for short-term troubleshooting. Some tables update so constantly that they create massive log volumes with almost no long-term value. If you don't distinguish between these patterns, the system will still capture the history, but you'll be paying to remember low-value noise at the same price as high-value evidence. That isn't governance, that is just undifferentiated retention. As that log volume grows, the consequences eventually move beyond just being a financial issue. Heavy auditing on frequently updated entities can add storage pressure and make your backups much heavier. Cleanup becomes harder, and your actual visibility drops because the platform is recording more data than your organization can ever realistically use. The question has to shift from should we audit to something better. What specific memory has enough business value to justify premium retention? That is the conversation leaders should be having. For some tables, like HR data or sensitive security approvals, long retention makes perfect sense. You might need years of history for legal reasons. For other tables, a shorter retention period is the more responsible choice because the value is in operational debugging, not permanent evidence. Microsoft's tools now support more selective approaches, including specific retention policies and table-level deletion options. We are no longer stuck with one blunt policy if we are willing to think structurally about our data. This is where architecture discipline becomes vital again. Your audit history should stay close enough to your operations to provide traceability, but not every analysis task needs to live inside Dataverse forever. You can use export paths like Azure Synapse Link to move that audit data into a better environment for long-term review or lower-cost storage. This doesn't mean you don't have to make decisions. It just means you have more options than simply storing everything in premium capacity and hoping the finance department never notices. Because eventually finance will notice. By the time they do, the wrong habits might already be embedded in your system. I would frame audit retention the same way I frame every other Dataverse decision, by its purpose. Use auditing where traceability reduces your risk or helps you explain system behavior. Keep that retention long, where the legal or operational value truly demands it, but keep it short where the value decays quickly. You need to monitor which tables are eating up your log capacity and treat selective auditing as a form of discipline rather than a compromise. If you remember nothing else from this section, remember this. Accountability is incredibly valuable, but unmanaged memory quickly becomes architecture debt. The platform has the capability to remember almost everything. That does not mean your business should be paying to keep everything in the exact same way. And that brings us to the objection that almost always shows up at this point. Once leaders see the need for premium storage, premium governance, and premium discipline, they ask the question everyone eventually asks, isn't Dataverse just too expensive? Dataverse is expensive, and that is the wrong first question. Now we come to the objection that usually arrives with a certain tone of confidence. Dataverse is expensive. To be fair, that statement isn't exactly wrong. When you compare it to Excel, SharePoint lists, or other tools people already feel they've paid for, Dataverse often introduces a much more visible cost line. You have to think about premium licensing, capacity planning, and specific choices for database, file, and log storage. If you only look at the entry price, Dataverse can look like the more expensive answer very quickly. But here's the thing, entry price is not the same as system cost. That distinction matters because most organizations do not actually suffer from cheap tools, but they do suffer from the expensive compensation required to make those cheap tools work. You see it in extra reconciliation, manual controls, duplicate records, and awkward permission workarounds. There are reporting delays, fragile automations, and constant cleanup projects that eventually lead to massive migration projects once the process finally outgrows its original foundation. Those costs rarely show up as a single license line, and that is exactly why leaders underestimate them. So when somebody tells me that Dataverse is expensive, my first response is usually to ask what stage of the life cycle they are talking about. Compared to the first week, it might be. Compared to year 2, it often isn't. This is the pattern most teams miss. SharePoint and Excel feel cheap because the platform friction is low and the spend is already hidden inside your broader Microsoft 365 licensing. But as the business process grows, the cost shape changes and the organization starts paying in labor instead of licensing. Labor is where architecture debt gets very expensive very fast because every weak structural choice begins demanding human attention just to keep the process coherent. You aren't actually saving money. You are just shifting cost from licenses to complexity. That is why cost-first comparisons can be so misleading for a business. They often compare one visible cost against a collection of invisible costs that sit in different budgets, different teams, and different kinds of pain. Support feels it, operations feels it, and the people inside the system feel it every day, but the finance view may still say the cheaper tool won. From a system perspective, that is a measurement problem rather than a proof point. Now, I'm not arguing that Dataverse is always the right answer, because it isn't. If your use case is small, flat, and unlikely to grow in complexity, then using SharePoint lists may be perfectly reasonable. The research supports that. SharePoint fits simple collaboration well and comes without additional licensing in many setups, so this isn't a morality play where every list is wrong and every premium table is wise. The real question is pressure. What happens when the process needs stronger relationships, row-level security, server-side logic, or cleaner delegation? What happens when the list becomes an app, then a workflow, and then a reporting source that leadership relies on for big decisions? That is where the cost conversation needs to mature, because the business is no longer just buying storage. It is choosing what kind of failure it wants to pay for. You can pay more upfront for structure, or you can pay later for rework. And later is almost always more expensive. Migration is a perfect example of this. Many teams start in SharePoint because it is fast, but then they move to Dataverse once scale and security needs finally catch up with them. That second move is not just a data move, it is a full redesign where relationships need to be rebuilt and logic needs to be relocated. Apps need to be reconnected and reports need to be updated, which means the cheap start often becomes the expensive middle. That is the wrong kind of economy. A better cost question sounds more like this. Which foundation reduces downstream complexity for the process we actually expect to run? If the answer includes automation you can trust and data quality you can sustain, then Dataverse may be the more economical decision even when the license line is higher. Because being economical is not the same as being cheap. Cheap lowers entry friction, economical lowers lifecycle friction. If leaders ask that second question early enough, they avoid one of the most common regrets in the power platform, which is building something popular on a foundation that could never really carry the weight once success arrived. The 4 decisions leaders need to make before scaling. If leaders want to avoid that year 2 regret, they need to make 4 decisions early. And I mean early enough that the platform still has a defined shape. Once apps spread across teams, every delayed decision returns later as rework or friction over things that should have been defined before the growth happened. The first decision is ownership of the data model. Who decides what the core entities mean, and how do conflicts get resolved when different departments want different definitions? This is where it becomes an executive call. If ownership stays vague, teams will still move forward, but they will move forward in parallel with local meanings and shortcuts that feel harmless until your reporting and automation start disagreeing. One customer with 3 meanings and 4 versions of status is not a data issue, it is a leadership gap showing up in a table structure. The second decision is your environment strategy. Where can people build? Where can they test? And where can the business actually depend on what was built? This sounds operational, but it decides whether innovation becomes repeatable or just leaves messy traces everywhere. If leaders allow the default environment to become the place where serious apps quietly accumulate, they aren't choosing agility. They are choosing weak visibility and support problems that arrive late, whereas a clean environment strategy gives useful work a safe route to become trusted. The third decision is the access model. You don't do this after the first permission crisis or after duplicates have already spread. You do it before. Who needs to see which records, at what level, and under what role? If that isn't designed early, the organization starts compensating in all the wrong places. Private copies appear, hidden lists appear, and sensitive fields get moved elsewhere because the original model cannot support controlled visibility. Then people say the platform got messy, but the mess actually started when security was treated as a later enhancement instead of a core part of the model. Weak access design fragments truth, while strong access design lets one record serve many roles without multiplying into copies. The fourth decision is ALM, or Application Lifecycle Management. How does change move into production? Who approves it? And how do we recover when a release causes damage? This is the decision leaders often postpone because early growth feels manageable. A few makers and a few apps feel personal enough that informal change still seems acceptable. But once the business depends on those assets, that informal change turns into operational risk very quickly. If there is no release path before production matters, then production becomes the place where design, testing, and repair all happen at once. That isn't speed, it is just avoidable risk disguised as momentum. The reason I group these 4 together is simple. They are not technical admin choices sitting below your strategy. They are the control points that decide whether the platform grows as infrastructure or grows as local improvisation with some branding on top. Ownership prevents semantic drift. Environment strategy prevents sprawl. Access design prevents duplication. ALM prevents release fragility. If you ignore any one of those, the failure mode shows up exactly where you would expect. Without an owner, teams reinvent the same entities, and without boundaries, your assets scatter. No access design means truth splits into copies, and without a lifecycle path, every update carries hidden risk. The platform may still look productive from the outside, but internally, it starts absorbing complexity in all the wrong places. So before anyone asks which app to build next, leaders should ask 4 plainer questions. Who owns the model? Where does change happen? Who sees what? How does change move safely? Once those decisions are made, Dataverse stops looking like a premium product choice and starts looking like what it actually is: infrastructure for shared operations. When that clicks, adoption gets much simpler because the conversation shifts away from features and toward the places where the current pain already proves the foundation is too weak. What adoption should look like in the real world. Once those four decisions are in place, we have to face the reality of adoption. I want to talk about what this actually looks like in a real organization, not what you see on a vendor slide or in a proof of concept workshop. We need to move past the platform strategy decks that confuse high-level enthusiasm with actual readiness. Healthy adoption should always start where pressure is already exposing structural fragility. It shouldn't start where the loudest person in the room wants a new app, and it definitely shouldn't start just because a demo would look nice for leadership. You need to look for the places where the current process is showing you that the foundation can no longer carry the load. Usually that means a process defined by cross-team friction, endless manual work, and a total lack of trust in the current data. You will see a visible delay between taking an action and making a decision because people are constantly checking each other's numbers before every meeting. Approvals drift through inboxes for days because nobody fully trusts the live state of the project, and reporting requires a translation layer because no one can point to a single record and call it the truth. That is your starting point. Adoption works best when Dataverse solves a structural pain that people are already feeling in their daily lives. If you start with novelty, people might admire the platform for a moment, but they will inevitably go back to their old behaviors once the excitement fades. When you start with pressure, the platform earns immediate credibility because it removes a burden that was already costing the company time, trust, and control. The order of operations here matters much more than most teams realize. First, you build the model, then you design the app surface, then you layer in the automation. Finally, you create the analytics projection. If you reverse that order, you simply end up with the same old broken patterns wearing slightly better tools. Teams often rush to screens because screens are tangible and easy to show off, but then they end up automating around weak records and reporting on top of ambiguous meanings. Later on, they discover they built a lot of speed on top of a foundation that is drifting away, which is a disaster that is completely avoidable if the model comes first. In a healthy adoption path, the first question is never about what the app should look like. Instead, we ask, what are the core entities? Who actually owns them? How do they relate to one another? What states are considered valid? Who has the authority to change what? Where does the authoritative record live? These are slower, harder questions to answer at the start, but they reduce downstream negotiation and conflict dramatically. Once the model is clear, the app becomes much simpler to build, automation becomes safer to trigger, and analytics becomes a projection of governed operations instead of a desperate attempt to reconstruct them after the fact. Visible wins are important, but the wrong kind of win creates a culture that will eventually fail. If your first success story is that you built a cool app in 2 days, the organization learns that speed is more important than structure. A much better visible win sounds like cycle times dropping because approvals no longer wait in email or duplicates falling because one record replaced 5 different trackers. When audit readiness improves because the change history was already there, side systems start to disappear because the operational model became trustworthy enough to retire them. That is adoption grounded in business reality. The people inside the system do not need to love Dataverse as a product. They just need to trust the system more than the manual workarounds they built to survive before it existed. Trust grows when the first use case is chosen with extreme care. You should pick one process that already spans multiple teams, specifically one where ownership and status have become so ambiguous that people are forced to compensate manually. When the cost of not fixing the model is already visible to everyone, you solve it deeply enough that the business feels a physical difference in how work moves. It is about how the system functions, not just how the app looks. This is why I avoid rolling out Dataverse as a broad, abstract initiative. Saying we are adopting Dataverse across the enterprise sounds ambitious, but it doesn't actually tell anyone which pain point is being removed. Adoption scales much better through one structurally important process at a time, where each success proves that better data foundations reduce the cost of coordination. That proof compounds over time. One process gains a governed model, and then another team sees the reporting get cleaner. Another group sees permissions handled without duplicate lists, and soon another sees automation running from a single trusted record. The conversation eventually changes from "why are we paying for this" to "which process should we move next?" That is what healthy adoption looks like. It isn't feature theater or app sprawl with a premium label. It is a structural improvement that people can feel in their daily work and leadership can recognize in the bottom line. If you want a practical next step, I suggest you audit one live process that currently runs across a mess of lists, spreadsheets, and inboxes. Map out the entities, the ownership, the access rules, and the handoffs before anyone even mentions a screen or a button. You need to ask one hard question: where does the truth live, and who is allowed to change it? Pick the use case where a poor structure is already slowing down the work or blocking trust, because that is where Dataverse will prove its value the fastest. Once the data foundation finally holds, Your apps, automation, and AI will stop fighting each other. They will start compounding instead because the business finally put one governed operational model underneath all of them. If you audited your human connection systems the same way you audit your technical infrastructure, what would you find? Is your current system designed to sustain the business, or is it slowly draining your resources over time? So let me leave you with the shift that matters most. Dataverse is not just a storage upgrade for your data. It is an operating model decision, and once you see that clearly, a lot of confusing platform debates start collapsing into one simpler question. Can your foundation carry shared business reality without forcing people to compensate around it every day? Excel and SharePoint lists are not bad tools, but they are often asked to do work they were never shaped to carry. While they lower entry friction and feel efficient at first, these tools also raise structural fragility under pressure because the business keeps adding coordination costs where the data layer should have absorbed them. And that is why this conversation matters so much now. Power Apps, Power Automate, reporting, governance, and Copilot do not sit above the foundation in some abstract way. They depend on it. If the structure underneath is weak, every capability above it gets more expensive, less trustworthy, and harder to scale. The app may still launch and the automation may still run, but the business will keep paying a hidden cost just to hold the whole thing together. So audit one process differently this week. Do not look at it as a workflow diagram. Look at it as architecture. Look at the entities, the ownership model, and the access rules to see where truth splits and duplication starts. When you find places where people keep rebuilding context by hand, you will realize the friction probably is not random, it is a system outcome. If this kind of thinking helps you translate Power Platform decisions into business reality, subscribe to the channel, leave a review if you are listening on the podcast, and connect with me, Mirko Peters, on LinkedIn. Tell me what should come next: Dataverse, Power Apps, Copilot, governance, or the failure patterns you keep seeing inside your own Microsoft estate. Every app already depends on a foundation. The only question is whether that foundation can still hold when the business finally starts relying on it.